Hi guys, welcome to my channel Electrical for You. This is my third video on electrical design. My first video was about voltage selection and second video was about transformer selection. If you have not watched my first and second video, then you must watch it before watching my third video because it is a continuation of my first and second videos. In my third video, we'll be discussing about high tension cable selection. In the transformer primary side, we'll be using H.V cable. As we have discussed in our previous videos, the selected voltage is 11 kV and the transformer selected is 500 kVA and the rating of the transformer is 11 kV bar 415 volt. That is, the primary side must have a capacity of 11 kV. Whatever cable we connect to the primary side, it must have a capacity to withstand 11 kV volt. In India, usually we select aluminum cable for the transmission of electricity as the economic factor is concerned. Normally, 4 types of cables are used in 11 kV transmissions. They are AYFI, A2XFI, YFY and 2XFY. I will give you a brief description on these cables by the end of this video. So, let's discuss the parameters required for the high voltage cable selection. The main parameter is the load current required to flow through the cable. Here, first we need to find out the load current required to flow through the primary side of the transformer. We can use an equation to find this out. The equation is kVA is equal to root 3 into kV into I, where kVA is the capacity of the transformer, which is 500 kVA, which we found out in our previous video, and kV is the required voltage in the primary side of the transformer, which we found out in our first video. So all the parameters except I is available in the equation. We can find out I by putting all these values in this equation. So we can find it out as 26.24 ampere. If we consider only the load current, then we can select 50 square mm cable in the primary side of the transformer. But it is not the case. We have to find out the fault current into our consideration in selecting the HV cable. For this, we have an equation. Fault current or short circuit current IS equal to fault MVA divided by root 3 into V. The fault MVA is given in the question itself, which is 250 into 10 raised to 6 and the voltage is 11 kV. By applying these values into the equation, we will get the fault current as 13.129 kilo ampere. The HV cable size can be found out by using the equation K into IS into root T, where K is the cable constant, IS is the short circuit current, T is the time duration of short circuit current. The value for ACB is 1 second, MCCB it is 100 millisecond and for fuse unit it is 5 millisecond. Here we consider ACB as the protection for our transformer. So we can take the value of T as 1 second. Now we can find out the value of K from the given chart. As I mentioned before, there are 4 types of cables. And first one is AYFI, which is PVC insulated armored aluminum cable. The value of AYFI cable is 13.16. Next type is A2XFY cable. which is XLPE insulated armored aluminum cable. The value of A2XFY cable is 10.64. Another type is YFY cable, which is PVC insulated armored copper cable. The value of YFY cable is 8.7. And the final type is 2XFY cable, which is XLPE insulated armored copper cable. The value of 2XFY cable is 7. As I mentioned before, in India, as economic factor is concerned, we usually prefer aluminum cable. So we can select A2XFY cable as our primary feeding cable. So the value of K will be 10.64. By applying these values to the equation, we will get the result as 139.69. And as you know, we don't have such size cable, so we will select the immediately available next size, which is 150 square mm. If we choose 2XFY cable as the primary cable, then the value of K will be 7, and by applying this to the equation, the selected cable would be 95 square mm cable. So finally we select the economic cable A2XFY, and the specification of the cable is 3 core 150 square mm 11 kV A2XFY cable. Remember, these cables are not applicable in inflammable working conditions like in petrochemical stations or in refineries. Let's have a look on the structure of the HV cable. On the left hand side, the bulged metal part is the core of the cable, which would be either aluminum or copper. It is the conduction part. Then you can see a conductor shield followed by XLPE or PVC insulation, then insulation shield, a copper bonding conductor, copper tape shield, fillers, binder tape, PVC inner jacket, aluminum or galvanized steel armor. Then at the peripheral side, we use PVC outer jacket. The shielding of the cable is done in order to eliminate the corona discharge, leakage current and capacitive current, thereby reducing the possibility of insulation failure, electric stress and electric shock. The major difference in the type of cable used are, first one is the conductor type and second one is the insulation used to protect the cable. The main conductors used are either aluminum or copper, and the type of insulations used are PVC or XLPE. The PVC insulation is cost effective but less durable compared to XLPE insulation. The XLPE insulation is a thermoset material while PVC insulation is thermoplastic. That is the main difference. So this is the end of the session. In the another session, we will be discussing on the generator selection. If you need a detailed lecture on electrical design, kindly watch my blog on electrical design. The link is given in the description. Please don't forget to subscribe for getting more information regarding the electrical design. Thank you for watching my video.